Hello. In this video, I am going to show you some of the problem from moment of couple. Okay? So, you already know from the theory that um, couple moments is something when the equal and opposite force is working on any rigid member. Okay? So this is problem number 4-68. You can see this one is saying a twist of 4 Newton meter is applied to the handle of a screwdriver. Resolve this couple moment into pair of couple forces F exerted on the handle and P exerted on the blade. Okay, so this is your screwdriver, and you are applying 4 kilonewton meter torque here. You are just trying to see that how much force is actually working here and how much force is working at the head here. Okay, so to do that, you can see, if you think about here, then basically your torque is or moment or torque, whatever you say, this one is 4 Newton meter is actually F multiplied by the distance here. So this is F multiplied by 0.3. That's actually converted that millimeter to meter, okay, because this one here is meter. So you can see that your F would be equal to 133 Newton. Okay, similarly, if you think about here, because you are applying that rotation here, and if you see, this one will actually have the same torque here. So you can see for the head, you can see P multiplied by 0.005, that actually 5 millimeter, that's equal to 4 Newton meter. So your P would be equal to 4 divided by 0.005, which is actually 800 Newton. So you can see actually you were applying only force 133, but because of the size of that moment arm, or the distance between the couple here, actually making that force much bigger. Okay, so basically you understand that like the size of this one and the size of this one actually very, very important for this screwdriver. Okay, now let's move forward. Now I'm gonna show you problem number 4-76, which is saying that determine the magnitude of F so that the resultant couple moment is 12 kilonewton meter counterclockwise. Okay, where on the beam does this resultant couple moment act? Okay, so first thing you have to just say that determine the magnitude of that force so that the resultant of this couple and this couple would be total equal to counterclockwise 12 kilonewton meter. Okay, and then the second question is like asking the where on the beam does the resultant couple moment act. Okay, so the first one, let's try to see here that I have one couple. This one is rotating, and I know the distance between these two forces, and this one is definitely counterclockwise. You can see here actually the distance between this point and this point is 0.3 meter, but this is actually slanted here. We need, for 2D cases, actually we need the shortest distance between two forces here. So what we usually do, we just dissolve that force here and here. So if I do that, then basically you can see this one looks like so this one looks like F so this one is F cosine theta, cosine, so this one was 30 degree, and this one is minus F cosine 30 degree. And then this one is minus F cosine sine 30. Actually, I'll just say that F sine 30, and this one is F sine 30. Okay, I don't need that one because the direction actually showing that one is negative. Okay, so you can see they are equal and opposite and going concurrently, so they don't have any moment. Okay, so if I assume that let's say that counterclockwise is positive, then the resultant moment is basically 12, okay, 12 kilonewton meter. That would be the moment of this two couple here. For the first couple, this is counterclockwise, so positive 8 into 1.2 plus, because this one is also counterclockwise, so F cosine 30 multiplied by the distance, which is 0.3 meter. Okay, so if you solve for F here, (12 minus 9), let's say 8 into 1.2, divided by cosine 30 into 0.3. So that's actually 9.24 kilonewton. So if this force here 9.24 kilonewton, then basically the resultant of moment would be equal to 12 kilonewton. Now the second part of that problem is asking, like, on the beam, where on the beam does the resultant couple moment act? Actually, your couple moment is actually a free vector, okay? Means like wherever you take the moment, actually you will get the same value. So it doesn't have any fixed location on the beam, okay? It can work anywhere. Now let's move forward. I'll just show you another 3D cases, okay? Now I am gonna show you problem number 4-92, okay? So 4-92, what I already drew it here, which is saying that the force here is 80 Newton and 80 Newton, that's a couple moment, okay? Now they are saying that determine the magnitude of that couple moment and find out the magnitude and direction angles of the couple moment. The pipe assembly lies in XY plane, okay? The pipe assembly is actually in that black color here. So you can see this is your pipe assembly here. So this one here is 300 meter, this is 200 meter, this is 90 degree, and this is also 90 degree here, okay? Now for 3D case, if you have a couple moments, then you can see here I drew this one here, like this is your F and this is your negative F. So you have to find out any point on the line of action of this force, which is B here, and in this force is A here, okay? So the position vector, the moment is basically the position vector RAB cross product of F, okay? Or I can also write RBA cross product of minus F. Any one of them would be fine, okay? So here, let's try to find out which point on the line of action actually is known point, okay? Let's say here, this point A here, you can see the X is 0.2, Y is 0.3, and Z equal to 0 because this is in XY plane, okay? Now let's say this is point B here. You can see your X equal to 0.3, Y equal to 3 plus 3, 600 plus 200, so 0.8 and 0. Now let's write the position vector. RAB, that would be B minus A, so 0.3 minus 0.2, that's 0.1 I, plus 0.8 minus 0.3, that's 0.5 J, plus 0 K, okay? Now you can just write the force vector here. Force vector is basically 80 K, since this is upward, so it's positive, okay? So the moment would be IJK, and this one is 0.1, 0.5, 0, 0, 0, 80. Okay? Now you have to just take your I, then cancel this one and this one, so this minus this. Okay, so this minus this, actually 40 minus 0, so that's actually 40I. Where you get J, then basically this one and this one doesn't have any value because both of them is 0 minus, or actually there is a value here. So you can see minus J, so cancel this one, so this into this, so that's actually 0.1 into 80, that's actually 8 minus 0. And then if you got your K, then you can see this minus this, so there is 1 0 and there is 1 0, it's actually 0. So you can see we have 40I minus 8J. So that's the that's the moment of that couple, okay? Now what is the magnitude of that moment? You can see the magnitude. This is actually your vector here. So your moment is actually root over 40 square plus that's basically 40.8 Newton meter. Okay. Now you can see your alpha, which is the angle with the x-axis, is equal to cosine inverse 40 divided by 40.8. That's actually 11.3 degrees. Your beta, which is the angle with the y-axis, that would be 8, actually negative 8 by 40.8. That's going to be 101 degree. And your gamma is actually cosine inverse 0 divided by 40.8. That's actually 90 degree. Okay? So that's your answer here. Thank you for watching.